Hello everyone, this is your tutor AB, and today we're going to be solving a problem from the November 2016 IB physics examinations. This is a paper 2 HL question and it's open-ended. It's a three-part question. So let's get started. Curling is a game played on a horizontal ice surface. A player pushes a large smooth stone across the ice for several seconds and then releases it. The stone moves until friction brings it to rest. The graph shows the variation of speed of the stone with time. Okay, so here we have a graph and they're telling us that the total distance traveled by the stone in this 17.5 seconds, so from here to here, is 29.8 meters. Part A, determine the maximum speed v of the stone. So if we think about it, there's not much we can do here. We can't use any of our Suvat equations. We're missing something here or there. So why don't we use the graph directly, right? And what do I mean by this? Well, this is a velocity time graph, and the area under a velocity time graph is displacement. We are given displacement and we know how to calculate the area of a triangle. So what if we can equate the area to the total displacement and then solve for the height? Take a look. We can say that the displacement for the first 3.5 seconds S1 is equal to half the base, which is 3.5, into some height. And what does this height actually represent? This height represents our maximum velocity. We know that S2 is equal to half the base, now it's like 14 seconds, into some height, again h. So what we know is that when we do S1 plus S2, we should get 29.8. So let's do that, shall we? So I'll do it quick. So in my head I know 1.75h plus 7h is equal to 29.8. So h is equal to 29.8 divided by 8.75, and this gives me, if I put it on my calculator, I get 29.8 divided by 8.75. I get the answer to be 3.40 meter per second. That is the maximum velocity of this curling stone. That is this point right there. Max velocity is equal to 3.4 meter per second. Okay. Next, B. Determine the coefficient of dynamic friction between the stone and the ice during the last 14 seconds of the stone's motion. Well, okay, so let's think about it this way. What's happening when the stone is moving on the ice? Some force is acting on the stone, correct? And there's only one force acting on the stone, which is frictional force, right? And what is the equation for force? We know F is equal to ma, F net in this case. And we know that the F net in this case is just equal to the frictional force. There's no other force acting on the stone. So the formula for frictional force is mu times N is equal to ma. Now, what is N in this case? Normal. What is the normal force? So if you think about it this way, we have a curling stone right there and it has some weight, W. The floor, due to this weight, has a reaction force on the stone. That's the reason it's not going through the floor. And that is actually your reaction force, normal, N. So we know that N is equal to W. And what is W in this case? Just mass times gravity. So instead of normal force, I can say mu times mg is equal to ma. M and M cancel. So I know that mu, which is the coefficient of dynamic friction, is equal to A divided by G. Now I need to find out what's the acceleration of the curling stone in the last 14 seconds. I can do this using the Suvat equations. The simplest one would be V is equal to U plus AT. Now how would this work? I know the final velocity is 0. The initial velocity I've calculated is 3.4 because they're saying last 14 seconds, and during the last 14 seconds this is the initial velocity 3.4 plus a, which is what I want to calculate, times last 14 seconds. That's given in the question, 14 for t. Now if I solve this, a is equal to, we can just say take the magnitude, so it would be 3.4 divided by 14. Of course we know it's decelerating, but we can take its magnitude, so that's 0.241 meter per second square. Okay, but that's not our full thing. We need to find mu is equal to a by g, hence it's equal to 0.241 divided by 9.81. That gives us the final answer as 0.025. That is our coefficient of dynamic friction. Okay, 0.241 divided by 9.81. Yes, 0.0245. 0.0245, which I rounded to 0.025. And of course the coefficients of dynamic friction has no unit, so it's just as it is, 0.025. That's your answer. And finally, part C, diagram shows the stone during its motion after release. Label the diagram to show the forces acting on the stone. Your answer should include the name, the direction, and point of application of each force. Well, we kind of already did this before. We know there is a weight which always comes from the center. There is a weight, let's give the name properly, which is equal to mg. We also know that there is a normal force, and we know that the only other force acting on the stone is right there, parallel to the surface, which is friction. And these are your three forces. You get 1, 2, 3. So okay, that's it for this video. Thank you for watching. If you need help with anything, please comment below. I'll answer as soon as possible. And please like and subscribe. See you in the next video. Thank you for watching.